in-person math class. Okay. So we're going to start with some simple ones.
We didn't have like anything, did we?
It was a review.
Like we didn't have to.
No. E-learning, you don't have to do Google Meet.
I'll really have to go.
I'm also very happy about that.
I definitely.
That's so good a little bit. Let me work that now, please. I spoke so
Okay, so I have given you the equation, negative 2x to the 6th power equals negative 1,458. Somebody tell me how you would solve this problem.
Divide by.
Okay, just raise your hand because I heard you talking first. Okay, what do I do?
Divide the negative 2 first.
Why wouldn't I take the 6th root first?
Because there's a negative 2 in front of it.
And that would just be horrendous. Let's not do that. So divide that out first. Good. So when I do that, I get x to the 6th equals what? Is that actually what it is? It is. 729. You wrote the notes already. Now what would I do? Okay, so I would like to factor the 729 and hopefully pull a 6th root out of it, correct? That's our goal. We're not always going to have these numbers that come beautiful. So there is a way for us to decide what our 6th root is going to be or if it exists without having to use our calculator. So we're going to try factor treeing this one because it's a really good practice. So what multiplies together to get 729? Numbers. Wow, I never would have thought. Use your calculator. Divide out 2. See if that works. If it doesn't, we try the next one, which is 3.
3 times 243.
3 and 243. Okay. 3 is prime. 243 is not. So I need to see if I can break that one down farther.
3 and 81.
3 and 81. Good. 3 is prime. 81 is not. I need to see if I can break it down farther. I heard 9 and 9. Neither one of those are prime, so I need to break them both down farther. What times what equals 9? 3 and 3. So each of those breaks down into a 3 and a 3. Which means the prime factorization of 729 is 3 times 3 times 3 times 3 times 3 times 3, right? 1, 2, 3, 4, 5, 6. Which means I had 6 3s, so I can rewrite it as 3 to the 6th. This helps me because now when I take the 6th root of both sides over here, I'm going to have x equals the 6th root of 729, which is 3 to the 6th. What happens with both of those 6's? They cancel, leaving just x equals 3.
Everyone gasped.
Questions, concerns, or issues with that one? Anybody confused by anything we just did? No, we're good? Yes, both.
Where's the other 3s?
What other 3s?
There's never mind.
Are you sure?
I was thinking three 3s plus 3 3s, but I did not. I don't know what it is.
Okay. Okay. Let's do another one. This time I have x cubed minus 9 equals 31. Amanda, how am I going to start this one? Add the 9 to the other side. Good. I like the way you're thinking. When I do, I get x cubed equals 40. Reese, what next?
Would you do the 3 squared thing?
The cube root? Yes. Eventually, you guys will get the lingo. I know the cube root and the cube on this side cancel, leaving me with just x equals the cube root of 40. Again, I'm going to factor tree 40 because I want to see if I can pull a group of 3 of anything out of that. So what multiplies together to get 40? 2 and 20. 2 is prime, 20 is not. What multiplies together to get 20? 5 and 4. You also could have done 2 and 10, it's your choice. 5 is prime, 4 is not. What multiplies together to get 4? 2 and 2, which means the prime factorization of 40 is 2 times 2 times 2 times 5. Because I had 3 2s and 1 5. I can rewrite that as 2 cubed times 5 because I had 3 2s there. Which means under this cube root, I don't have 40 anymore. I have 2 cubed and 5. How is that helpful? This cube is going to cancel out with the cube root, so that 2 is going to come out. Is the 5 going to come out as well? No, there are not 3 of them there. There's only 1, so it stays. Which means x equals 2 times the cube root of 5. How do we like this?
It's so difficult. I think we should just do something like this.
Really? Okay, so let's do one more and then we'll get into some special cases. Christina, what do you think I'm going to do first? Subtract the 12 over, good. When I do, I get the negative of x plus 3 cubed equals 72 because 84 minus 12 is 72. Delilah, what next? Do I want to distribute it or do I want to get rid of it? I can't distribute it unless I cube the parentheses, and that seems like a lot of work right now, and it's probably not even what I really want to do. So maybe we should try getting rid of it. How would I get rid of it? Divide negative 1 from both sides. Good. When I do that, I'm left with the quantity x plus 3 cubed equals negative 72. My goal is to get x by itself. So what do I now have to cancel out? The cube, the exponent 3 right there. What root am I taking if I'm trying to cancel a power of 3? I should hear more than 2 people saying it. What root should I take if I'm trying to cancel an exponent of 3? The cube root, the same root number has to be canceling it out. So I'm going to take the cube root of both sides. I know on this side, the cube root and the exponent are going to cancel, leaving just x plus 3. On the right, I have the cube root of negative 72. Is that possible? Yes, because it's an odd exponent. Negatives are 100% possible. From here, I'm just going to factor it the same way, or simplify it the same way. I'm going to have to factor tree 72. It's the only way I can do this. So I'm going to take 72 and I'm going to break it down. What multiplies together to get 72? I heard 9 and 8. That's what I'm going with. 9 is not a prime number, and neither is 8, so they can both break down farther. 9 breaks down into 3 and 3, both of which are prime, so I'm good there. 8 breaks down into 2 and 4. 2 is prime, 4 is not, so it can break down farther, and it breaks down into 2 and 2. So my prime factorization for 72 is 2 times 2 times 2 times 3 times 3. Yes.
Oh.
Of course, I can rewrite those using exponents instead of repeated numbers. So that is the same as 2 cubed, 3 squared. And that's what I'm going to replace the 72 with that is under the radical.
What about the negative?
The negative, I just go ahead and put with the base that I know is going to come out. You could also write it as -1 times 2 cubed times 3 squared. Same thing. The -1 is going to come out because -1 times -1 times -1 equals -1. So I'm going to have the negative cube root of, is either the 2 or the 3 going to come out? The 2, because it has an exponent of 3, which is going to cancel with the root 3 I already have there. So the 2 is going to come out, and the 3 squared is going to stay under. So I have x plus 3 equals -2 times the cube root of 3 squared. I still want to get x by itself, so I still have to do something with the plus 3 over here on the left. How do I get rid of a plus 3? Subtract it over. When I subtract it, it can't combine with anything, so I have -3 minus 2 times the cube root of 9. I went ahead and multiplied that 3 squared back into a 9.
Wait, then.
Why can't
Could you have left it?
3 not?
Because this is 2 times the square root of 9. So if this had a square root of 9 or a cube root of 9, I could have done it. But since they don't contain the same radical, I can't put them together. You could have left it as 3 squared if you wanted to, but the less exponents I have, the easier it is to understand. But that's your choice. Questions, concerns, or issues on that one? No? So now let's talk about radical equations in general. So a radical equation is exactly how it sounds, and it is an equation that contains radicals and has variables either inside of the radical or being multiplied into the radical. Also, it is important to note that when we are solving radical equations, no matter what root we are taking, we are working only in the set of real numbers, so we can't have any complex numbers, no i's. Okay, so if we're taking the square root of a negative number or the fourth root of a negative number, it's no solution because that doesn't exist in the set of real numbers. Okay, so this is just kind of a formal definition. It is important to note that all radical equations exist in one of 3 cases. Okay, so it can all be broken down into 3 separate types of radical equations. The first one we're going to look at is case 1. And these are equations where the variable is not under the radical. And it is in 2 separate terms. There are a few steps for solving this specific type of radical equation. The first step is to move the terms with the variables together. I'm going to use W with the dash for width because I get tired of writing it. Step 2 is to factor the x out, or the variable, whatever it is. Step 3 is to divide by the coefficient, or whatever is still being multiplied into the x. Step 4 is to rationalize the denominator. And step 5 is to, step 5 is to check our solutions. We could get something called an extraneous solution, which means that when I solve it, I get the answer, but when I plug it back in, it doesn't actually work. So I like to call these fake solutions. We have to check for those here. We're also going to make the assumption that if I'm taking the square root of something or the fourth root of something, that I'm only taking the positive. Okay, that's going to make it a whole lot easier for us working through these. So let's go ahead and do a couple case 1 examples. The first example is x plus 1 equals x times the square root of 2. I have 2 examples per type or per special case, sometimes 3. We're probably not going to do all of them, but know that they are in the notes for you to look back on. So this first one, I have an x on 2 separate sides of the equal sign in 2 different terms. So what is my first step here? What do we write as our first step? Say that again, Miranda. Move the terms with the variables together, which means I need all the terms that have an x on it on one side of the equation. Since that one's already over there, we're just going to go ahead and move this one to the right. So when I move it, I subtract it. So now I have 1 equals x times the square root of 2 minus x. What is step 2? Factor the x out, which means I'm going to divide it out of each of these terms and then put it in front of them. So this becomes 1 equals x times x root 2 divided by x is just a root 2 minus, what's x divided by x? 1. So this becomes x times the square root of 2 minus 1. I just divided x out of each of those terms and then put it in front of the parentheses. Yes. Now what do I do? What's step 3? Divide the coefficient. That means whatever is currently being multiplied into my x, I need to get rid of by dividing it out. So I'm going to divide both sides by the square root of 2 minus 1. Which means when I do, I'm going to go ahead and move the x to the left so it's easier to read. I have x equals 1 over the square root of 2 minus 1. We know from previous lessons that we can't leave a square root in our denominator. So this is where step 4 comes in, where it says to rationalize my denominator. So my goal is to get rid of that square root. I just moved the x over to the side.
What happened to the square root of 2 minus 1
On this side, it stayed.
the x?
With this one, it canceled. It's just like having 3 times x divided by 3. It cancels itself out, which is the whole reason of doing that. If I want to rationalize the square root of 2 minus 1 as a denominator, what am I going to multiply by? The conjugate, the square root of 2 plus 1. I know we missed this already. So of course, when I multiply it into the numerator, we just multiply straight across. So 1 times the square root of 2 is just the square root of 2. 1 times 1 is 1. So my numerator becomes the square root of 2 plus 1. I have a binomial times a binomial in my denominators. So I'm going to have to FOIL that bad boy. So when I FOIL it, we do our first terms together first. Square root of 2 times square root of 2 is the square root of 4. Square root of 2 times a positive 1 is positive root 2. Square root of 2 times negative 1 is negative root 2. And then negative 1 times 1 is negative 1. I notice, of course, that positive root 2 and negative root 2 are going to cancel. Which means that I have x equals the square root of 2 plus 1 over 2 minus 1, because the square root of 4 is 2. And then what's 2 minus 1? Square root of 2 plus 1. That's my answer. Because
Oh, wait, no more.
if I were to take he asked a really good question. So why is it still a square root? We don't want to change that into a decimal, first of all, because that would be a rounded value, and we don't do rounded values here. We're very, very smart, so we can do exact values, so we're okay with leaving a radical there. And a radical is 100% okay to be left in the numerator, just never in our denominator. I know step 5 said to check your solutions, but when you get something like this, that's really hard to check. So I'm okay if you don't check it if there's a radical left in your answer. If you get a whole number, though, I expect you to check it. How do we feel about that one? Okay. There is another example there if you would like to do it. I'm not going to go through it with you because it's almost exactly like this one. So we're going to go ahead and move to case 2. Sorry. So case number 2 says there's one variable and it is inside of my radical, which means the steps to solve it might be a little bit different. First step is to isolate the term with the radical. Step 2 is to undo the radical. We like to think about this as an inverse kind of, or an inverse operation. Step 3 is to solve for the variable. And then step 4 is to check your solutions. We're going to do 2 examples on this one, and then the third one is yours to look at if you so choose. The first example is the square root of 2b plus 2 minus 3 equals negative 15. Before we get into this, I would like to address something that I saw a lot when you guys were graphing radicals. Are we all looking up here? I'll give you a second if you're not done writing. This plus 2 and this minus 3 could not be put together. This one exists under the radical. This one doesn't, which means they are not the same numbers, and they're not both whole numbers technically, because this one is technically the square root of 2. They cannot be put together. So some people like to go ahead and draw like a little partial wall at the end of their radical to indicate this is where it stops, which kind of separates terms. That is entirely your choice. Just don't let it get confusing if you start to think that's an exponent of 1, because that can happen as well. I reiterate, this plus 2 and that minus 3 cannot be put together. You also need to be very careful about where you're drawing your radical and making sure it extends over the proper numbers. If it's under a radical in the problem, it needs to be under a radical in your paper or in your work. Okay? That's not just something pretty we draw for the heck of it. It serves a purpose. It alters our numbers. Okay? Are we all okay with that? That is something I saw a lot. I didn't count off if you did all of your work correctly from that point on because we hadn't spent a lot of time on it, but I will be very, very picky on the test about that. Okay? So now continuing on, my goal is to isolate the b term and solve for b. So what's the first thing that I need to move? The negative 3, because step 1 said to isolate the radical, which means to get the radical by itself. To do that here, I need to add the 3 over to the other side. And when I do, I get the square root of 2b plus 2 equals negative 12. What was step 2? Undo the radical, which means I need to raise it to a power that's going to cancel out the root that's happening. Here I have the square root, which means to cancel it out, I need to raise it to what power? 2. I need to square it. So what we do to one side, we also do to the other. This square is going to cancel out that square root, leaving 2b plus 2 equals, and then negative 12 squared is equal to 144, not negative 144. Let's make sure we remember that. Brandon, what do I do next? I don't want to divide yet. I want to do something else first. Subtract the 2 over first. We don't want to really divide until the b is by itself. Okay, so subtract the 2 over. I get 2b equals 72. And now we can divide by 2. That's not 70. I know what I'm doing. I really do. Sorry, I jumped the gun. So subtracted 2, and I got 144 minus 2 is 142. Now we can divide by 2, and I get b equals 71. Sorry about that. So I did all of my steps, correct? No.
Check.
Now we need to check our solution to make sure it is a real solution and not an extraneous solution. So what I mean by check it is I mean take this number, plug it back into the original problem, and see if it works out. So that's exactly what we're going to do. So I have the square root of 2 times 71 plus 2 minus 3 equals negative 15. I can go ahead and simplify what's under the radical. 2 times 71 is 142 plus 2. I'm going to add the 3 over, and I get negative 12 on the right. I can go ahead and put 142 plus 2 together, and I get the square root of 144 equals negative 12. When I square root 144, what do I get? Okay, remember when I said for the purposes of this problem, we are assuming when we take the square root, we're only going with the positive answer. So in the end, I get 12 equals negative 12. Is that true? Is 12 equal to negative 12? No. So this is an extraneous solution, which means technically we have no solution because we got no other answers.
So on the test, if this was like one of the problems that would be
You would put no solution, yeah. Yep. So even though technically in our brains we know that the square root of 144 can be both positive and negative, that still would have given me 2 answers where this one only gave me 1, so it still wouldn't have worked out, which is why it's okay to take only the positives here. That only applies though if I'm taking an even root. So if I'm taking a cube root or a 5th root or a 7th root, I need to pay attention to the sign on the number inside. Okay? Questions, concerns, or issues with that one? Let's do another one. Okay, so on this one, what am I going to do? Subtract the 2 over first. I need to isolate the radical that I have happening. Even though this doesn't look like a radical, this is a fractional exponent, which means there's a radical or root happening somewhere. So I need to subtract the 2 over. And when I do, I get that the quantity x minus 1 to the 2/3 power is equal to 4. Are we all okay there? Next step says to undo the radical, which means I need to multiply by whatever it takes to cancel my radical out. This is a little bit different because I have a fractional exponent, but the idea is still the same. I need to multiply by whatever I can to make that fraction go to 1. Anybody have an idea of what I can multiply by? or what power to take it to. 3/2, just flip the fraction. So both of these sides, we're gonna take to the 3/2 power. On this side, those cancel each other out, and I'm left with just the x minus 1 equals. Then I have 4 to the 3/2 power. If I were rewriting that as a radical, because that might be helpful for me, that would be the square root of 4 cubed, because my denominator was 2, which indicated a square root, and then my numerator was 3, which meant I was raising my answer to a power of 3. So I simplify that right-hand side because I can't do anything else until I do. What's the square root of 4? 2. What's 2 cubed? So I get x minus 1 equals 8. Then what do? Add the 1 over, and I get x equals 9. Do I just accept that that is my answer? We have to check it. And we're going to check it by just plugging it back into the original problem. And solving it out. So the first thing I'm going to do is I'm going to figure out what 9 minus 1 is. What's 9 minus 1? 8. Good. So this means that I'm taking the cube root of 8 and then squaring my answer. I know the cube root of positive 8 is what? Positive 2. So then I have positive 2 squared plus 2 equals 6. What's 2 squared? 4. So now I have 4 plus 2 equals 6, and I know 4 plus 2 is 6. So I end up with 6 equals 6, which is in fact true, which means x minus 9 is an actual solution. As always, I typically prefer your solutions to be written in curly brackets, especially if we're talking about numbers like this. Yes, ma'am.
I subtracted the 2 over right away, and
That's perfectly fine. As long as whatever you're left with is equal, you're okay. That was 100% okay.
How do you want to start to like x equals curly brackets?
Yeah. Because sometimes you'll get more than one answer. Sometimes you'll get no answers.
Is this for all the answers?
Yes, this should be for all of yours.
How'd you write that so fast?
Right, what? I write a lot of curly brackets, okay?
Do it and it
That's okay. I still have kids who've been in my classes for like 3 years who still do curly brackets like that.
That's what I do.
Or they do just like 3s.
One side looks good.
That's usually how it goes. Okay, questions, concerns, or issues with that one? Case 3 it is. This is our last one. This one's my favorite. The hardest.
So that means it's like
It requires the most amount of work, yes.
yes.
So that's why we're probably just going to do one of these. Like this one, of course. But they're all pretty much the same once you do one. So in this one, case number 3 says the variables in 2 separate radicals. Step 1 is to separate the radical terms. So that they are on opposite sides of the equal sign. Step 2 says to undo the radical just like before. So we're going to use the inverse. Step 3 is to isolate the remaining radical, because there will be one left, usually. says to undo the radical again. Step 5 is to solve for the variable. And then step 6 is to check your solutions. And again, we're just going to do one of these because they're all pretty much the same. If you do want an extra example, though, after we do this one, there is one in the notes. Okay, example. So I have the square root of x plus 1 minus the square root of x equals -1. Sarah, what do you think we're going to have to do first? If you're not sure, check the steps that we just listed out under case 3. Separate the radicals to opposite sides of the equal sign. So right now I have 2 radicals to the left of my equal sign. Which one do you think it would be best to move? The first one or the second one? The second one, because it's currently negative, so when I move it, it's going to become positive. So when I move it, I literally mean move it like you would any other number. So I'm going to add that across. And when I do, I get the square root of x plus 1 equals -1 plus the square root of 3x. What is step 2, Caitlin? Undo the radical. So lucky for me, these are both the same radical, and they will be for the purposes of this class. So what would I do to undo this square root right here? What would I multiply by or take the power of? I would square both sides, right? Let's make sure when we're squaring that right side that we're not squaring each individual term. We're squaring the entire side. Okay, so on the left, it's going to be really nice because the square and the square root are going to cancel. And I'm going to have x plus 1 equals. On the right, it's not quite as nice because this means that I have -1 plus the square root of 3x times -1 plus the square root of 3x, which means I'm going to get to FOIL this. So that's exactly what I do. -1 times -1 is +1. -1 times the square root of 3x is -√3x. -1 times the square root of 3x is -√3x. √3x times √3x is the square root of 9x squared. So I'd multiply the 3x and the 3x together. And I still have the x plus 1 over here on the left. Now I need to simplify that right-hand side as much as I can. So -√3x and -√3x become -2 square root of 3x. And then what's the square root of 9x squared? Just 3x. Square root of 9 is 3. Square root of x squared is x. So that is as simplified as I can go on that right-hand side, which means that I now have to isolate this radical because I still have to undo that. So these 2 terms are going to have to move to my left-hand side. So I'm going to subtract this one, and I'm going to subtract this 3x. We're getting there. X minus 3x is -2x. 1 minus 1 is 0, so that cancels out. And then equals -2 times the square root of 3x. I'm gonna pause here, just make sure everybody catches up. Elijah, what do you think we're gonna do next? Before I even do that, you could do that, but you might have some extra work involved if we don't do this first. Divide the -2. So as Elijah said, technically we could go ahead and square this, but that's a little bit of extra work and unnecessary at this point. So what I like to say is until there's nothing in front of that square root, we cannot square it yet. So to get rid of that -2, I need to divide both sides by -2. I see that is going to work out beautifully for me because my -2's are going to cancel on both sides. And I'm going to have x equals the square root of 3x. And now, just like Elijah said, we're going to go ahead and square both sides, which is going to leave me with x squared equals 3x. There are two ways that we could solve it from here. We could divide each side by x because that's 100% okay. Or we could move the 3x over to the left-hand side and factor it like a quadratic and then set each of those parts equal to 0. Which one would you like to do? I like dividing by x as well. So we're going to divide both sides by x. The good news is if you had done it the other way, 0 would have been an extraneous solution anyway. So still comes out the exact same. So one of these x's cancels with that one, leaving just an x on the left-hand side. These two x's cancel, leaving me with x equals 3. Are we all okay with how I did that? So now what do I do with that x equals 3? Plug it back into the original problem and see if it works out. Spoiler alert, it will, but we should still check. So when I plug it in, I have the square root of 3 plus 1 minus the square root of 3 times 3 equals -1. 3 plus 1 becomes 4, so I have the square root of 4 minus 3 times 3 becomes 9, which makes that the square root of 9. Square root of 4 is 2. Square root of 9 is 3. 2 minus 3 is -1. So x equals 3 is a solution and should go in curly brackets. And then we're done. So of course, if you want some extra examples, they are in the notes. Please feel free to look at those as you need to. If not, your homework is on Canvas and it is 5 questions. And there's no multiple parts to any of them. I know, right? I was feeling generous.
We just did like what?
But we have